this is not going to be a good one to record actually, but that's okay. So we're going to talk about nested iterations today. And we've been learning about enumerables and how we iterate over collections, over arrays and hashes. And now we're going to pick up the complexity a little bit and practice, because sometimes we need to do like an enumerable inside of an enumerable to get at some data and to join data together. So we're going to start looking at more complex iteration patterns today. We're going to do a lot of practice, and we're going to utilize our pry as a debugging tool to really help us see what's going on. I've said this before when we were talking about nested collections, but it all goes back to like the fundamental basics of iteration. If we can remember how to iterate as over an array, over a hash, we're just going to build on those fundamentals to help us navigate more complex structures and nested iteration patterns. Okay, but it's all about building on those fundamentals. So for our warm up, I'm gonna have you here. I'll put this in the channel as well, so you have it. But I'm going to give you this animals array, and I want you to use an enumerable to accomplish these 3 tasks. So go ahead and either just jot it in a notebook or do it in a text editor of your choice. But let's take about 3 minutes to work on that as a warm up. Okay, Aiden, yeah, let's go ahead and help me out with some code here.
Cool. We could do animal string for like the variable name.
Like this?
Yeah, or strings, plural. And equals animals.map. And do, and then we could probably just call it animal.
I love that.
Sweet. And then, yeah, and then for the code, we could just do animal.to_s. Yeah.
Yeah. And then let's run that and check it out. That looks good to me though. So we're just, and why did you decide to use a map?
Because we're trying to return a string or an array. So.
Returning an array with the same number of elements, right? But each element is transformed, right, in the same type of way. Awesome. So if we look up animal straight, oh gosh. Awesome. Yeah, that looks good. So right when we want to, thank you so much, Aiden, for that. We all want to always think about these enumerables and what their job is, what they're doing. So with map, whenever we want to return the same number of elements, but transformed in some kind of way, then we can use map. And that would be a good one. You could still use, if you wanted to, dot each and shovel this into some kind of container, and then have that container out here. Container, okay. So that is still acceptable. But I do want you to get into the practice of using things like map, especially map, because that one is used so often, whether you're working in Ruby or other languages. All of them have something, not all of them, a lot of them have something like map that will transform the collection you're working with. So we definitely want to get good with map. Awesome. Let's do the next one. Return an array of animals with length greater than or equal to 4. Cool. What do we think? Someone want to come off mute and help me with the code for this one? Adam, go right ahead.
All right. Mine didn't return strings, but you can help me figure that out. I did similar to what Aiden did, animals underscore array equals animals dot map dot find all.
Map.findAll.
That's right. And then do animal. And then for the next line, I tried to get a string, so I did animals dot to underscore s dot length greater than or equal to 4. And then I just printed the array.
Mm-hmm. Cool. And so let's see, I think this will actually work.
It doesn't get strings though, but
yeah, okay. So the chaining of enumerables, actually we can't chain enumerables in this way. If we want to chain enumerables, we have to wait for the block to finish running, and then we can chain it afterwards. So if we get rid of the map though, right, then we're using our find all, which will find all the animals that fit this condition. Oh, it would help if I had these together. That fits this condition, and then we'll put it into this animals array. And now the way we have it, remember, find all does not transform our elements for us. So if we start with symbols, we're going to end with symbols, and that's just how find all works. And that's okay. I didn't actually specify in here if I wanted strings or symbols. So let's run this and see what we get with animals array. Cool. So now we have all the ones here that are longer, or 4 are longer. So this works. Cool. So it's okay that we didn't turn it to a string. If you wanted to have turned this to a string, then the next step, it's like a 2-step process. You could do animals array and then do this, basically map it to strings. And that would do that for us. But we can't chain enumerables up here where we're first calling them. There's some that you can, but then they're not enumerables.
Yeah, is there any reason why it worked for me when I chained it? Or was it just unnecessary?
Hold on, let me, because I had a syntax error, so that's why it wasn't working for me.
Because I was trying to chain it so I can do that, turn it to strings at the end in one line, but it didn't quite work.
Yeah. No, so yeah, exactly. So it's calling a map, but there's no block being passed to it. So it's just saying, okay, we'll just work with the same thing then. And then it's performing the find all. So if you want to actually chain something like that, you can, well, I don't recommend this. You can chain like enumerables to the end of this like that, but I do not recommend that because it's highly unreadable. So what I would do is just do it in 2 steps, right? Find the thing, or find the elements that you want, and then perform do this again to turn them to strings.
Thank you.
Yeah, absolutely. Cool. Any other questions about either the find all or this map method or enumerables that we use to accomplish these 2 things? Cool. And we're just again reviewing more of our more fundamentals with enumerating over a single collection, because then we'll build upon that complexity. All right, how about this one? Return a hash where the keys are the animal and the values are the length of that animal. So like dog has 3 characters. Yeah, V, go ahead.
Let's see. So I created hash equals an empty hash.
Okay, let's call I like breakdown. Usually, like this one too, we typically don't want to put the data type in our variable name because that data type can change, and then we don't want to have to change all the variables. So maybe this one would actually be called like long animals, right? So breakdown, I don't know, it's not too different than hash, I suppose, but we want to try to avoid putting the name of the data structure in the variable name. V, awesome. Go ahead, continue.
And then I don't know if this step was necessary, but I created a new variable and did equal my iteration. I don't know if I needed that, but I call it third iteration equals, and then I start animals each.
Oh, okay. Yeah, if you're just using a dot each, we don't need to store that into a variable, because remember, dot each just returns that original collection. So we can just skip the variable piece.
Cool. So animals.each do animal, and then break down open bracket animal equal animal dot length.
Cool, that should work. We can still call dot length on a string. And sometimes if I'm not sure about, because I know dot length is a string method, but can I call dot length on a symbol? And I'm just kind of asking, like, if I had just been given this, I might just go into a pry session and then do a symbol like hello. And then can I call dot length on that? Oh, I sure can. So what if it was like hello there, dot length? Yeah, very cool. All right, so we can definitely call dot length on a symbol, and it seems like it's working as if this was a string. It's just giving us the character count. Very cool. So that should work. This looks great. Let's go ahead and run that and see if breakdown gave us the thing. 3, 5, 6, 7. Yep, looks like it did. So what V did here, thank you so much, V, this was great, is she called the name of the hash, assigned the key to the symbol of the animal that we're on, and then used her Simon operator to set the value of that key to the length of the symbol. Okay. And she used a dot each here, which I think is totally fine. You can use like an each with object or a reduce to condense this and get rid of this one line, but you certainly don't have to. Any other questions about this? Either the breakdown one? Sam, yeah.
How do you do that with reduce or inject again? I know you put like the hash as accumulator, but you still need to make breakdown as a variable outside of that scope. So it saves, right? Or
Not with, nope, not with reduce or each with object. The return value of those, and I'll show it here, the return value is the accumulated value. So you don't have to store it again. Alex?
I've never seen each with object, but someone in our group has talked about using it. Can you show me how to use that really quick?
Yeah, definitely. So each with object is actually a newer one. Some students started using it a couple innings ago, and I wasn't even aware of that one. So it's kind of cool. So each with object is similar to reduce in that it's taking a bunch of information and it's going to return a single thing, so a single data structure. Each with object will return either a hash or an array. So what we do with that one is here, it's an enumerable, and we have to declare what type of object we're building. And it's kind of like our default value. So we've got a hash here. With each with object, we get 2 block variables. And also this is if you learn how to do each with object or I'm sorry, each with array, it's each with object. If you learn how to use each with object or reduce, awesome. If this is like, I'm way lost, don't worry about it. We can do it the way with the each and putting it into an outside accumulator. That's totally acceptable. This is bonus material. How about that? So each with object gets 2 block variables. The first one being the normal enumeration or block variable we're used to. That's just storing the element. And then the second one is whatever we're going to name this accumulator. So we'll call it breakdown, since that's what we named it up here. I like that. And then this actually looks exactly the same, except what each with object is doing for us is it takes breakdown and just is accumulating that hash for us as we iterate through our collection. And then the return value of this, oops, oh, okay. Oh my goodness. Final count of my animals. So the return value of this will be that accumulated array. So if we go look at what final count is here, it is that array. And if you're looking to use reduce, it is very, very similar. Reduce is funny, like these are actually flip-flopped in reduce. The first block variable is your accumulator, the second is the object. But the weird thing with reduce is reduce stores in this, it's called a memo or an accumulator. What reduce stores in this is whatever this code evaluates to, whatever the return value is. The return value of this statement right here is actually just this piece, the animal.length. So what we have to do is after this runs, we have to then return breakdown in this code block so that that's the final thing to run in the code block, and then breakdown gets updated with each iteration. So that's kind of a funky thing with reduce, is that you have to call the accumulator at the bottom of the code block typically. You don't have to do that with each with object. Cool. And then this one should still work. Let's test it. Final. Cool. Awesome. But of course, using that dot each with an accumulator works just fine as well. This is bonus. Awesome. Any other questions about any of these? Map, find all, reduce, each with object, or just using each with an accumulator? Okay. If you do think of questions, please ask. Let's look now at a pretty simplified version of a nested enumerable. So sometimes, and a lot of you did use this in your battleship, so this might look familiar. We're going to practice with this nested structure with some with actual objects and instances today of classes. And so if we have multiple collections and we need to either combine the data in some way or access the first layer in order to get to the second layer, a nested enumerable is an option. So one thing we can do is, like, if we wanted all combinations of these rows and columns, right? We know that we want something like, we want it to go A1, A2, A3, A4. And then for the Bs, we also want B1, B2, B3, B4. So what we're doing here is we're iterating through the rows array, but for each element of that rows array, we're going to iterate through the whole columns array. So that's how we're going to structure this nested iteration. So if we do rows, actually let's do like an accumulator up here, combos. And we're going to store all the different combinations in this array. So if we enumerate through our rows, we've got each row here, right? And remember I said for each row element, then we want to iterate through every column. So we can call that second enumerable in here, or second collection, okay, sorry, I was gonna sneeze. Did not happen for me. And then let's drop a pry in there and kind of see what we've got going on. So a lot of times when I'm working in a nested enumerable, I will write the structure I think I need and then stick a pry in there to make sure I'm accessing everything as I am assuming. We always want to test our assumptions. So if we drop into that pry, I can see I'm inside of both enumerables. And so I should have access to both this block variable and this block variable, right? Because they're nested, I have access in scope to both block variables. So if I see row here, I do. Column, I have that here, awesome. Combos right now is empty. So if I do something like row plus column right now is an integer. So let's change it to a string. That would work. So let's shovel that into my column. My combos. Cool. And so that should work. So I think if we do that in our block, that will help us accomplish this. If I type exit and pry, remember it just continues running the code. So row should still be A, but now I should see that my column is on the second element of that columns array right here, since we're going through each of these. And then if I continue again, we should be on A3. Awesome. So that's how we can build this combos array. So I can just put that code in there that we looked at, column.2s. I might wrap this just so we could see exactly what's going on. But then that will go through each of the rows and then tack on each of the columns for every row element. And let's just verify that that actually did the thing. Cool, so that looks good. So that it just built all those combinations for us using a nested enumerable. Okay, Granted, this was a slightly simplified version. We'll work, like I said, with more objects to access data inside of objects in this nested structure. I think with nested enumerables, a lot of times it's easy to start with this kind of pattern where you're just doing a dot each, and then shoveling things into an accumulator. But you certainly can, once you get that working, start playing with, okay, well, can I use a map here? What would that do? Could I use a find all or even a reduce here? What would that look like? Just remember what the return values are, right? Because dot map for every element in the rows is going to return the return value of this. So as, sorry, let me reword that. The return value of the block is what map will transform the element into. So this one wouldn't actually work too well. Anyone know what would be transformed? Like what would be the return value from this? Any guesses? I think that is you, Sid. Posse Zoom.
Sorry, I don't know how I keep getting in these different Zooms. The original array from each.
Mm-hmm. Right. So remember, dot each returns the original collection it's working on. So every time this runs, it's going to return that original columns. So rows is going to map each element to that. So we're just going to get that columns array. See? Because this was the return value for each of those, the blocks, was just that columns array. So it mapped each element of this rows array with the columns array. So when you're going through a nested enumerable to think about, well, what enumerable do I want to use? Really think about what is the block returning and what is this enumerable looking for? If you can pull it apart and dissect it that way, then sometimes, then it's not just like, okay, let me try map, let me try find all, let me try that. Like, don't throw spaghetti at the wall and see what sticks. Just, think about it logically, and that's a good exercise. But again, you can always start with just the each and shovel things into that outside accumulator. I think that's a great way to start when you're doing nested enumerables. Cool. Questions? Any questions about anything nested enumerable like? Yeah, Sid, you changed your name.
I did. I was like, let's keep it. So the first iteration that you're like, the first enumerable that you call on rows. So like if you did call, this is where I start getting confused. If you did call a find all, it's going to find all within rows or whatever's in that. Like, that's where I get confused. What does that?
Yeah, that's a great question. And I think that's where this can get very confusing. So let's think about it logically. And this question's not just for you, Sid, it's for everyone. All right, so think to yourself, what is test gonna hold right now? So what I want you to think is, what is find all looking for in its block and what will it return? So if this block stays the same, and what is find all return? So what is test going to be? So everyone just take a minute to see if you can work through this logically in your head and make a guess, and then we'll test it. Okay, everyone have a guess? Maybe? Let's see. So let's see what it holds. Is that what you thought? No? Okay, actually, I really, really like this question. So remember how find all is working. Find all is looking, Ben, did you wanna pop in here?
Yeah, I think the actual block code in find all is a condition it has to meet, right?
Well, kind of.
Like it's looking at like find all of the things that match what's happening in the block, right?
Kind of.
Okay.
So what, sorry to be so vague with that and cryptic. That's my specialty, I guess. Find all is looking for its block to evaluate to truthy or falsy, right? So if this evaluates to truthy, then find all will say, okay, that matches the condition. I'm just looking for this block to evaluate to truthy. And since it evaluates to truthy, return the element that made that block truthy. Well, we just saw what is this returns the actual columns array, right? Because dot each returns the original array. And an array is a thing, it evaluates to truthy because it's not nil or false, right? So because dot each in this block here is evaluating to an array, then each of the row elements for find all is evaluating to truthy, which means this find all is going to take every element from that rows array. Remember, find all does not do a transformation. So it will always return the same elements you started with. But since everything evaluated to truthy, that's why we're getting back that original array and all elements of it. Okay, so that was a really good question and a really good exercise. And what I had kind of just mentioned is that really think about what is this block looking for and what is it returning and how does this nested enumerable play into that? Because you've got to now think about the return value of this inner block and the return value of this outer block. Yeah, Sid?
Sorry. Just one. So why is test equal to the return value of the first one and not the return value? Okay. I always think of the inside enumerable as being the, like it has, like its order of operations. So I always think the inside one takes precedence over the outside one. So I was thinking that test would be equal to that.
Yeah. So it's all, think of it this way, and this is why indentation is important. This is an outer block. And so the find all is the outer block that's actually running. And we could put a million things inside of this, but because that find all is the outer structure, it's like the wrapper over all the insides that's going on. So it doesn't really matter what these insides are that's going on. The return value of the whole block is going to be what the outer wrapper is, which in this case is the find all. So whatever find all is returning is what this entire block will look to return. So you want to look at that outer layer, that outer structure. Does that help a little bit, Sid?
Yes. And so then this inside each, I guess what's hitting this code, the block of code, what's controlling that?
I don't have this in like a class or a method or anything. So Ruby's lit when I run this file, it's just running top to bottom.
Okay, got you. Okay, thank you.
Awesome. Yeah. V?
So is it, because you said you can put a bunch of stuff inside the block and it's not gonna matter. So is it like, as long as the outer block enumerable is returning what you want to return, it doesn't matter so much which enumerable you use inside, as long as it does the job.
Right, as long as it does the job. So depending, like different situations, we'll call for a different thing in here. Like maybe we wanted a map. Well, actually, the map wouldn't matter so much there because we have a find all here. So this is just looking for some, this to either be truthy or falsy. So you could do another find all inside of here, right? And then this one might return, well, actually, no, this one would still return everything because the find all, if it doesn't find it, still returns an empty array, which is still truthy. So this would still come back with all the rows. So the point is, right, this can get confusing really fast. This the outer structure, the outer wrapper is what's going to determine, like your final return value from the whole block. And then you just have to kind of think about, okay, well, what is it that I'm actually looking for inside? What do I want this to do? And that's why I say starting with just dot each with an accumulator is really good. And then you can start working through, okay, well, if I'm transforming values, I know normally I would use a map. Could I make one of these into a map, and would it give me the same structure? Sometimes with a map, when you have a nested data structure like this, if you have like a map and a map, you might get a nested array back, so like an array within an array. And so calling like a dot flatten at the end of it is typically a pattern that we'll see a lot with a nested enumerable. So that dot flatten it'll run everything, and after it runs all the whole nested enumerable, then it will flatten the final return value. So if you're using maps and you're getting like a nested data structure, just try calling a dot flatten at the end of it, and that will usually help.
What is your logic when let's say you're doing an exercise, you start with each, and then you start questioning if like there's a better enumerable to use there. What is the logic to decide where you're going to change the enumerable?
That's a good question, and I think it's so like situational. Like in this case, I don't think I could use another enumerable. Well, maybe like a reduce, but I couldn't use like a map or a find all because I'm creating a bunch of combinations. So like a map to me, right, I'm still returning the same number of elements, maybe, right? This is a hard one to explain. I think this question B might be better explained after you do some of the practices exercises that we're going to go through, because there are some situations where I think the thought process might help. But I think if we're really just wanting to say, okay, I'm trying to think back to that last independent challenge we had, but I think there was like, or say you had like, what was the last challenge?
Was the buildings one?
The what?
The building one, with like
The
all
building. Okay,
Yeah.
so yeah, I don't know why I can't even remember this one. We even did it together. You have like buildings and something inside of the buildings, right? So you have two objects, and one is nested within the other. Oh, it was like apartments and renters, right? Kind of thing. And so if you have like you have a building, that in the building there's an array of all the units, and you just wanted to like say, okay, give me all the units, you might, or the renters of the units, right? That's typically a nested structure, because we have to go through the units and then we have to look into each of the units to get to the renter. But we can still use some kind of map in there, even though we're not necessarily ending with the same number of elements. This is where it gets so like confusing with map, right? Because we might be getting back like an array. So we still have like 5 elements, but each element is an array of another 3 elements. And that's still a map, it's still transforming, but then in the end result, we want to flatten it all and just get an array that's got like 50 elements.
Yeah, that makes sense.
Maybe that was so confusing. Does it? Okay. All right. I think when we go through some of the exercises, we'll see a situation where we could use a map. And so maybe we can talk through a thought process together once we get to that one.
Okay, thank you.
Yeah, definitely. The other thing I'll say about nested enumerables is a lot of times, not every time, but a lot of times you can break it up into 2 steps. So it's actually not a nested enumerable. You could say, do this step and then save it in a variable and then do the next step, right? And then you kind of unnest that structure. Which way is correct? I think it really just depends on the situation and what you're trying to achieve. So, you get another it depends answer with that one. For the sake of the exercises we're going to do in breakout rooms after the POM, I'm going to challenge everyone to use nested enumerables, right? Maybe once you get it working with a nested enumerable, if you want to break it out into 2 steps, so it's a little more segmented, you can do that. But I really want you to practice using this nested data structure or this nested enumeration. Okay. All right, any other questions right now? And then we're going to take a POM and then we're going to go into breakout rooms. I feel like a lot of what we're talking about right now is very like theoretical, and like we need to get to some applications so we can get our hands dirty, right? All right, well, I'll let you sit with this. I'll ask for if there's any other questions when we come back from, open it up to any questions. If anyone thought of anything over the palm that they wanted to ask, either about single enumeration. I don't think that's actually what this is called, but just the single iterating over a single collection, or a nested iteration. Not yet. All right, let's play in it, because I think once you play in some examples, more questions will come up. So I'm going to drop a repo into the your Slack channel for you to clone down. We'll have one person screen share. So I really, really encourage you to have that screen share in your breakout room, because it just gives you a place to all look at, so that you can discuss things together. It's much easier to discuss it when you can all look at the same thing. But you're going to be working with classes and doing nested enumeration within classes. So building methods that do this nested iteration. And so your object is, there's a README you'll want to look at, but you're going to be making tests pass, basically. So I just dropped that into your Slack channel, and I'm going to go ahead and open up breakout rooms, and I'll pop around to see what questions you have. Any questions about what you're doing in your breakout room? Let's resume recording. And so we don't go over time. So cool. All right, so let's go through some of these and just kind of see how far we get together. But I definitely want you to, if you had questions, ask questions. That's definitely what this time is for. So in the README, wherever that is, we are starting with the course test, and then moving on to school test, and we'll unskip all the tests. So the first thing that we'll cover is that course test. And we see, well, let's just run it if I'm not sure where it is. So actually, let me get into this. Okay, so test, course test. Oh, why is this not? I don't want a CD, I want a Ruby test, course test. There we go. Cool, so I've got, oh, no errors. Well, that's bizarre. Oh, I should unskip it, and then I should get an error. Cool, so I have got, it found the methods, which makes sense because I did write a method here, but it's returning nil when what we're expecting is an array of symbols representing the house names that these students are associated with. So what I would do first in here, and then I'll actually have someone help me write this code, but I like to show, whenever I'm not quite sure, I will write the method and then put my pry into that method. That way, when the test invokes that method, it hits it, and then my pry will pause the program, and then I have access to whatever variables I would have access to when I'm actually writing the code for that method. Cool, so here I have access to, I can see a course has a name, a professor, and then it's got this list of students. And ultimately, I want to get at the students, and I want to get at the house of each of those students. So if I take a look at what @students holds, it is an array. And so this is what I'm interested in, is this house. And so if I can take each element, and instead of returning a student object, return their house, that should get me what I want. We'll have some duplicates, that's okay. We always handle duplicates at the very end. So what did you all do? What did you do to get at this house is represented? This one's actually not nested iteration, but that's okay. It's kind of like our warm-up. Do I have a volunteer who would like to help me? Maybe someone who hasn't spoken up yet today would like to help me write this code. Yeah, Karen.
Okay, so first we want to set up an empty array of houses.
Okay.
And then we want an each block, so students dot each do student.
Okay.
And then we want to shovel in to our houses array, student dot house. And go ahead and close that. Oh, did you already close it? Yes.
Mm-hmm.
And
yep.
after that one, houses. call the houses, yep, and then dot unique to get back no duplicates.
Mhm. Yeah,
That's-
yeah, so perfect. Yep, thank you, Karen. I'm gonna run it without the unique so we can see what it gives, and then I'll add that back in. Cool, so we can see we do get what we want, but we've got the duplication. And so I always say like zero in on how to build it, not worrying about duplication or dupes. And then at the very end, just like Karen did, we can add that dot unique to our final return value. And that will just make sure that we get rid of any duplicate elements. And so then that should pass the test. Cool. So we can definitely do it like this. We can use this outside accumulator. Thank you so much, Karen, for helping me with this one. And she's just going through each of the students. And for each student, she's accessing that house because that's we zeroed in on that piece of information that we want. And then we're shoveling it into this accumulator here. Now, what's another way we can write this and condense it just a little bit? Did anyone use a different enumerable for this one? Everyone did this exact same way? Mike?
We use map, and and then
Okay.
on 6, yeah, and then we just put dot unique on the end of map.
Okay, so you didn't have this accumulator and you changed this to map, right? And then did you just put it like this?
Yeah.
Okay, yeah. So again, so this is another way you can do this. If we're just shoveling something into an outside accumulator, that's totally fine. That will get the job done. But if we know we're transforming every element, right? Because what we had first here was an array of student objects, and we wanted to change or transform each element into its house, the symbol. Then we can use a map to do that for us. We get rid of this house so we don't have that outside accumulator. So what this will do is for each element in the students array, it's going to override that student element, or sorry, that student object with the house of that student. And then after this entire block runs, we can call a dot unique on it. If you don't like that, you can store this in a variable like this. So houses, and so this block will then be stored here. And then you can call houses dot unique like that. But you don't have to. You can just tack the dot unique onto the end of the do end block and it'll accomplish the same thing. Gus, question?
Yeah, we used each with object. We used a guard clause in the block to prevent having to do the unique at the end.
Okay.
But we don't have to get into that
Interesting.
if you don't want.
Well, no, that's fine. I'm just thinking about like, I like each with object. I would just say be careful with overusing it. Because I think map honestly is the best enumerable for the situation rather than building like using this like you're building a brand new structure, and dot map is, I guess it's kind of building a new structure underneath since it is returning a new array, but it's just that's what the return value is. Well, I guess they're both doing that, but I like the simplicity of map a little better than each with object in these cases. To me, the use case for each with object is if you're starting to build something a little more complex, or you've got like multiple collections you're iterating over and you want to build something a little more complex. If we're just wanting to return these houses, I think that a map is probably the best use. Of course, with Ruby, as we're seeing, there's a million ways to accomplish a thing. So if you ever did this with an each with object, like on an independent challenge or something, it'll work just fine. But I think map is probably the most readable in this case.
Okay.
Bea, do you have a question? Yeah, thank you so much, Gus, for sharing what you used.
Yeah, so
Bea?
with
Sorry.
this, oh, notice, with this syntax, if I wanted to avoid using unique, would I be able, I'm not able to figure out how to do a if statement inside the map because you don't have a variable. So my question is it possible to do a if statement in this syntax?
Yes, I don't think there's a problem though with doing unique at the end, because then it establishes what you're collecting, and then you're just saying, okay, now get rid of all the duplicates. Now I think though,
I think that Mike was kind of like weird about that and said that he didn't want to see that, I think.
With the dot unique?
Yeah, but like any calls in the end, like he expects to, when you are refactoring, you take that out. I think I could be making this up. I don't know.
This is super common. So I'd be surprised if, and maybe he does it right. You're going to find this across all instructors as well, is different preferences. And just know that this is totally okay. Like as a coder, you're going to start to develop your own preferences. Wherever you end up working, they're going to have a set of preferences that they're probably going to expect you to follow. And so there's always different opinions about like what's the best way to do it. You know, like some people are going to love using each with object with this, and that's totally fine. Using map and that, like, this is how I would write the code. This is my opinion on what the code is best here. I don't know that I'd want to do like an if statement or anything inside of here, just because it adds more complexity to my map.
Oh, okay. But it is possible.
Mm-hmm. Oh, sure. Like, well, in a map, if it already exists, I wouldn't do it with a map though, because like if you had an each, you could do it within each and then check it.
Yeah.
So say like, how did Karen have it? Houses like this, right? But then you could do a guard clause like if houses dot include student, whoops, the student dot house. Ooh, I don't like this already, but we want the negative, right? So to me, this is now I'm making this more and more unreadable, when with the map, I felt like it was very simple and pretty readable. So this, right, is saying I'm using that guard clause. So like if the houses does not include the student's house, then go ahead and shovel that into the house.
Right. Gotcha. Thank you.
So yeah. So there's only a million ways we can actually do this thing, right? So pick your poison, I guess. But I always encourage you to like err on the side of most readable. To me, this is super readable. It's nice and compact, doesn't go too far horizontal. Again, this is my opinion. Cool. Awesome. Let's move. I want to make sure we get into the school tests. So let me, we got it right here. And let's pull up school. Cool. So we've got these tests all work. So for my first skip, we're looking at test it can sort all students. And this is kind of weird. It's not sorting it like in the way we might initially think of sorting students in some kind of like order. What we're trying to do is take each student, because what we're doing is we're calling a method called sort students. And then we're making sure that each of the students has a house. And that's what this method here is doing. Sort, the method sort, where we pass it a student, is assigning a house to an individual student. And we want to make sure all the students in the school are assigned to a house. Like I would have liked this to be called assign rather than sort if I was writing this code, right? So let's go ahead and do the sort students. Well, I like to run it first to make sure there's no syntax errors. Undefined method sort students. Cool. So we'll do that. Sort students. And then I do this so like automatically. I write my method and then I just put a pry in there to kind of see what I've got access to. So I know ultimately I want to access each of the students so that then I can set their house equal to something. So how, from school, how I'm thinking, how can I get over to students? I've got houses. What is that, houses? Okay, it's just an array of all those house options. And then at courses, gives me each of the courses. And then in there, I see I can access the students, and then that's another array. And then from that array, I can access the houses. So we've got a couple levels. An array within an array is what I'm trying to get at here. So if I iterate through this array of courses, then I can grab the array of students and then go through the students to assign their house. What did you write for this? Does someone want to come off mute and share what their group did to get this method working and kind of share your thought process on it as well? Phil, awesome.
Hey,
Hey.
so we wrote this with 2 each blocks. So it
Okay.
started with @courses.each do course. And then within this block, we did course.students.each do student.
Mm.
And then we called the sort with student as the argument method. Sort method with student.
Like that?
Yeah, and that was it. And yeah, we kind of struggled with like the sort and thinking we had to like create a map something to a new array, but we realized we were just assigning the house to these students, and we had a adder accessor in the student class. So this uses that method essentially to define it for us.
Yeah, awesome. Totally. And then this method here, right? This one that was already written is doing that work for us. It's saying, okay, set the student house equal to just one of the houses. So it's doing it randomly. Awesome. Phil, this looks really great. And this is what I would have done for this as well. And I like your use of .each here, because really we don't actually care about the return value of this sort students method. What we care about is its side effect. So this is what's called a command method, as opposed to a query method. A query is like checking an attribute. A command method is doing a thing and changing attributes. So with sort students, since we don't care about the return value, we just want to affect some kind of change to a student object, then we can just do .each, because we're just trying to use that as a tool to access these different levels. Let me comment this out real quick too and put a pry in here, right? So if you know, like you have this array of courses, and each element is a course object. So we know we want to iterate through that, right? Pretty much anytime we have an array of objects, we probably are going to do some kind of iteration through that. So then if we put our pry inside of here and see what we got, then, so now I'm inside of my code block. So course here I can see is a single course object. And then we've got some students. So I could play in here and say, okay, well, if I did course.students, that gives me the second array here. And so that's when we can say, okay, so course.students gives an array and I want to iterate across each of these students. So would that work? And then we could stick our pry inside of that block. I'm trying to kind of show like a debugging process here, or a thought, like how you might figure this out. So here I see I still have access to course because I'm inside of the nested block. But then I have access to student, and then I can have access to student.house, which I don't actually need that, but the idea here is now I have a student object, which I can then send over as an argument to this method that's already written. So that's how I would work through this, thinking about this nested enumerable. Cool. Any questions about this method? I think that was a fun one. I like that it uses a helper method. All right, so let's test it can list all students by name. Oh, did we actually make sure that our test passed? We should do that. Cool. All right, so just one error, which is the test I just unskipped with student names. So here we want to list all students by name. So we would just want an array of the strings that represents all the students' names. So who wants to help me write this method? Student names. Any brave volunteers for this one? No brave volunteers? Does someone want to be voluntold to share? All right, Adam, go for it.
All right, we did not get to this, but no one's volunteering, so I can work it out with you.
I love it.
Is that
Even
helpful?
better. That's
Okay.
super helpful.
Student names. All right, where's the test? Testing can list
Yeah,
all
right
students by
here.
name, and we're supposed to build a method in school called student name. So you've got that. All right. So, I mean, if we just throw a pry in right here,
Do it.
we can just go to courses because that's the only thing we've added yet. Is that right? And I can see
Yeah,
that
I
every
agree.
course. Totally. So every course has a student. I'd run through the same logic you just did. So try to get to that student. So I'd put exactly like you did in the last example. I'd put a at courses.eachdo course. We already know that there's a bunch of courses with students. So I do course.students.eachdo again. We just went through that. And then we're not sorting this time, but we're just trying to get an array that lists all of them. So we could throw pry in there. Okay, we could type in student so we know like where we're at. Okay, and we want the name. So I would say student.name. Okay, so we know how to access it. And now anyone from the group, do you guys have any ideas on how we can take the student.name and stick it into an array?
Yeah,
Joe.
Joseph, go for it.
So we could make an empty array, name it students.
Yeah.
And then we could go ahead and shovel or write students and then make a shovel. And then students.name.
Student, right? The
Or
singular.
student.name, yeah, sorry.
It's all good. Those S's will get you every time, everyone.
Yeah,
Just wait for
and
Mod to.
I know that there is an issue still, but I guess run it to see that there's a.
Yeah. So what we wanted to get back is just this array of the names, but what we're getting back is the array of all the courses, which makes sense because the last block of code to run is this .each. Remember, we have to look at the outer structure to see what block of code. This is not the last block of code because it's contained inside of the .each. That's why indentation is super important. So the at courses.each is the last block of code. .each we know returns the original array, so that's what we're getting back. So Joseph, how can I make sure that this method's returning my students array?
So you could move outside of the block. So on line 33, we could do students. And we can do a .unique to get rid of any duplicates
Yes,
of names.
yes. Let me run it without that so we can just see where we're at. Yeah, totally. So now our method is returning the students array, which has been, because this block has ran, the student names have been shoveled into that array. It has been built, so we can return that. We do see we have some duplication here, and we're expected to not have any duplicates, so we can just add a little .unique to the end of that. And we're good to go. Awesome. Thank you so much, Joseph and Adam, for helping with that method. The other thing we can do with this is, instead of doing a .each with an accumulator, what I'm thinking is, would a map work in this case? Because we've got some transformation going on, right? We're changing a course to students, and then we're changing the students to a student name. So how might a map work in this case? Let's get rid of some of this stuff. I know a map, right? We'll first take all my students. And what if I did a map here too? Let me kind of start with this inner piece, right? So if I do course.students.map, well, course.students is an array of student objects. And if I map over that with the name, then that'll get me an array of student names for a single course. And so it will take that array and override the course object with an array of names of students in that course. So That's kind of what I want, except what I could see here is, right, I've got a nested data structure now, right? So it took course one and transformed it with the return value of the other map inside, which was the array of names, the strings. Did the same thing for course two, same thing for course three. So when I've got that happening, these are the names I want, they're just in a nested structure. So what I can do at the end of this do is I can call a dot flatten on it, and that will push this down into what's called a one-dimensional array, right? So now that looks much closer, but we still have those duplicates. So we can either then tack on a dot unique here, and then that will accomplish it. Okay, so you can use map in that situation. If map was like, you're like, I don't think I could figure that out, that's okay. Use that dot each structure where you're shoveling something in. Adam, a question?
Yeah, so I've used the flat map instead of map, and I know that does a slightly different thing. Is that just preference, or should we actually avoid that?
No, you can use flat map. So what flat map does is it is an enumerable in Ruby. So it's in the doc, so you can totally go for it. What it does is, this is so common, this pattern of doing a dot map and then a dot flatten at the end, that Ruby gives us an enumerable called flat map that does the same thing and just calls a dot flatten at the end of the map. So that will accomplish the same thing. Oh, we still need to call the dot unique on it though. Dot unique at the end of the outer block. And that's good to go. So yeah, you can use flat map. I tend to forget about flat map sometimes because other languages don't have a flat map. So if you forget flat map, just know you could do a map with a flatten. Either way, totally acceptable. Catherine, question?
Yeah, so my group, once we kind of moved on to the next one, we were wondering if it would be more kind of reasonable if this was an independent challenge to make a helper method. I mean, I know that that's a little bit outside of what we're supposed to be doing in this lesson, but I was just curious.
Totally. And here, I will give you my personal thoughts right now, okay? Which, remember, other developers and instructors' personal thoughts are going to be different than mine. It is my opinion that when we're doing a nested enumerable, that usually breaking it apart into two pieces and creating a helper method can allow us to have some additional like reusability of the code. Because I think I agree with you, Catherine. If this was ended right here, this is all we had to do, then this would be fine. But maybe as I move on, and let's use this as like a lead way into this next one, it can list all students by house. I'm looking here to say like, okay, I need to access each of the houses and I need to have an array of the student objects that are in that house. Wait a minute, right here though, I kind of did that, right? When I did a map here, if I didn't have the student name, I kind of did a map creating an array of students in each course specifically. So maybe I could break this apart into two pieces and then use one of that as a helper method and reuse some code here. So I think it takes some practice to recognize when we can do that. But I think it's a good practice. Typically, when I'm coding, if I have a nested enumerable, I'm going to break it up into two pieces because then I can identify helper methods a little easier. Do you have to do that? No, I don't think you do, but you certainly can. So what that would look like here, and I'm going to, for the sake of time, I'm going to kind of power through this last one. And so we can definitely put more questions in the thread in the code help channel. But what I might do here is first, maybe I just want to get a map or an array of all the students. So let's get rid of, let's do this. Sure, we'll keep the flat map, right? Because now what is this going to do? This is not student names, but this is actually, hold on. Yeah, let's do this. This is just like the students in courses. Oh, but this is over all the courses. Hold on, I am not refactoring very well. Okay, so student names, this will give us all of our students. Let me put a pry in here and see what we got. So students right now, see, that's my array of all, but this is an array of all the students. Maybe I could use that, maybe not, I don't know, let's see. And then, because if we had an array of all the students, then to finish out this one, the student names, we would just do a map over that array of all the students and pull out the name. And then that would be the return value of this method, which should pass that other test, which it does. This is the students by house one. So the other one passes. So breaking that nested block into two pieces now, it still works, but now what I can do is say, okay, I recognize this is two pieces. Let's make this a helper method called students. And if I had more time, we would be making a test for this right now, right? Get rid of that. So now what this is calling is not a variable, but it's calling my helper method. And that's going to go through all of my students for all the courses, return an array of student objects, and then I'm just going to map over each of those. I don't know, would I want a unique here? I don't know. I would, debate that. We'll keep the unique there. We could also put the unique here. I don't see it mattering either way for these tests. All right, cool. So that student name still functions now, but then if we're going to create this one, students by house, Catherine, so is this the helper method that you all created or talked about?
Yeah, it is.
Okay, and then did you utilize that to create this method?
Yeah.
Can you walk me through the code that you did?
Yes.
If you have it.
Yeah. So we did houses _ students to set it equal to
oh, got it.
Yeah, and then set that equal to, and then your method was called students dot each with object. And yeah, and with the hash brackets in there, and then do. And then we did student breakdown.
Okay.
Yeah. And then we said if breakdown, open bracket, student dot house. And then on the next line, breakdown, student dot house, and then we shoveled in student. And then else breakdown, student dot house equals student inside an array. Yeah. And then all the ends. Mm-hmm.
All the ends. So cool. We don't need to store it in a variable.
Oh, gotcha.
Since this is the only block of code you've got, each with object will return the accumulator for you. So you don't need to store it in a value. So what they did, okay. This looks great, Catherine. Thank you. So what she and her group did is they called on this helper method, right, which returns an array of student objects. So that's already, so we've got all the students here. We already called a unique on it, so we're not going to have any duplicate students. And then for each of those students, we want to build a hash, right, because that's the return value we're looking for right here, where the hash, the key is the house, and then the value is an array of students who belong to that house. So this is one solution to do that. First, we're checking, does that key even exist? So if that key does exist, then go ahead and shovel that student into the array that key is already associated with. If this returns nil, it means that house is not currently set as a key. And so let's go ahead then and set it as a key and then set it equal to a student inside of that array so that we create that array structure. And then each with object will go ahead and return a breakdown for us. If you were like, oh, I wouldn't ever think to use each with object, that's okay. You can use just a dot each and put a breakdown out here like this, and then just make sure you return it at the end of the method. This would accomplish the same thing. And that should help pass that. Wrong number of arguments, given 1, expected 0.
I think
Look,
on
the
line
bracket
40,
after
you would have the
line
bracket.
40. Sorry, what on my
I think
bracket?
it's
Oh,
bracket
yeah,
there.
totally. Don't need that with an H. Cool. Thank you. So that will accomplish the same thing. So that's one way you could use like a helper method. And that's the idea of this lesson, was to really get practice in a nested iteration on what that looks like. And you can go for nested iterations. A lot of times, in my opinion, nested iterations can be broken up like this into helper methods. Now, if you notice, this is still kind of, well, it's doing two iterations at one, two iterations on top of each other, because it's calling the students method, which is enumerating over the courses, and then we're mapping over that. So it is doing like one iteration then another, as opposed to doing both at kind of the same time. So it just depends. If we didn't have any other methods to build, I would say just keep this in a nested iteration. Like don't pull that out until you need to. I think Mike talked about that yesterday, the you ain't gonna need it kind of concept. Like don't refactor it until it's necessary to pull out a helper method. But then if you recognize in this one, oh, it'd be cool if I had an array of student objects, you'd be like, oh, that's kind of what I did up here. Then you can pull out a helper method to help you out with that. Cool. All right, we're a little bit over on time, but I want to just check if there's any final questions. Cool. What I'll encourage you to do is, if you did a different solution to the students by house, definitely drop it into the thread for this channel and Code Help, so we can see what some other solutions would look like for that one, especially if you didn't create these helper methods. Cool. Awesome. All right. Well, thanks for being here.